Our last lesson involves application. We're going to use angles from geometry formed by parallel lines, or formed by creating triangles, or formed by what we're going to call compass or angle bearings. We're going to create those bearings using given information, and then utilize law of sines and cosines to solve. We'll start by creating some direction. The course of a plane or a ship is known as a bearing, or an angle in which the ship or plane rotates, and it's always measured in a clockwise direction. We start at the due north location, almost like 12 o'clock, and then rotate clockwise. So as you can see, that little ship is rotating down here to the right. The first thing we're going to do is sketch possible bearings. We'll start with that north direction and we'll rotate the given degree measures. Notice each of them is going to increase in value. So here's what we do. It's pretty easy. We always start with just kind of a spot and then we just arrow up and there's our north direction. A 50-degree rotation, notice it's 0, 5, 0. We always use 3 digits. So if it's less than 100, the first digit stays 0. 50 degrees is a little bit more than halfway between north and then maybe east, like a right angle. So we'll just kind of rotate about that far, and that would be a 50-degree bearing. And that's all you do. The next one is 130, so that's obviously greater than 50. We start with our due north location. Now 130 is greater than 90, so we have to go beyond that maybe east direction and head a little bit further. 130, if we go about here, there's about 90 degrees. We need to go about 40 more, so maybe somewhere down in that direction. There's a 130-degree bearing. Now 330 is almost the entire way around the direction. If we start due north for 0, but rotate 330, here's 90, halfway around would be 180, 270, and 330 would be about in that direction. There is a bearing of 330 degrees. We're going to start off most of our pictures with some type of direction like this. Another way to create a course is by using a compass. And when we use that compass model, we call it now just a compass bearing. This will be written a little bit different than the course of a plane or a ship. A compass bearing is going to be an acute angle. So it won't be 330 or 330 or 130. It's going to start from the north or south line. Typically we start with the north line, but a compass bearing can be north or south. And then it will rotate towards the east or west by an acute angle measure. The example that's given is north 20 east. That means we're starting in the north direction, but rotating 20 degrees towards the east direction. We have to be particular to those directions as we create our new compass bearing. Let's try a couple of examples. Down below, example A, north 50 degrees west. That means we're going to start at the top like we normally do, but we're going to rotate in the direction of west. So here's where we begin, and if we rotate 50 degrees, it's a little more than halfway in that west direction. That's the direction in which we rotate. In the next example, it's even more unique. Now we're going to start in the south direction. So that means we start at the bottom, and we're going to rotate towards the east. We'll start here and rotate ever so slightly 20 degrees in that east direction. As long as you can determine the direction in which you're rotating, we should be able to generate our pictures. What's going to make this unique is when we have more sets of bearings in a given problem. Having just one picture is pretty easy to, or having one bearing is pretty easy to create. But if there's more than one, we're going to end up working with parallel lines and all different kinds of angles associated with them. So this last kind of set of pictures is a way to compare. For example, if you have a north direction, Oh, wow, that's a weird N, but that was meant to be an N. If you have a north direction, and let's say you rotate in a certain degree, and then you have another north or even maybe a south, those two lines would be parallel to each other. Do you remember drawing arrows on parallel lines in geometry? Well, if you have a situation like this, angle 1 and angle 2 have a specific comparison. They're not equal to each other, but they're called consecutive interior angles. In this case, that means they add up to 180. So we would say the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. That will be significant in our pictures as we try to generate triangular shapes. Another scenario would be if you have another north direction, and let's say you rotate a certain degree, and then maybe you change direction so you could possibly have another north, or you might have a south direction. Now that angle is on the opposite side. Notice it's not on the same side like it was in that first picture. In this case, these angles are called alternate interior angles, and they are actually equal to each other. And this will be helpful to us, again, as we create our triangles. And another scenario would be if you have just a plain compass bearing or bearing in one direction, angle 1, but then angle 2 goes all the way back around. Who can think of the comparison for these two? In this case, these two angles would add up to 360, and we would be able to determine our measures accordingly. Okay, let's put this to the test. What we're going to do today is just work on creating pictures from the given information. And then we'll apply law of sines and cosines in future days to help solve. Our first example, ship A spots ship B on a bearing of 84 degrees. What bearing will B spot A with? So we're just going to kind of work backwards with that. Well, let's read the directions in order. Ship A spots ship B. What that means is I'm just going to pick a point and label that for A. There's ship A right there at that dot. If the bearing is 084, what I'm going to do is just create my due north. That's kind of our starting point for the rotation. So there's A, there's my due north, and I'm going to rotate 84 degrees. It's almost a right angle, like so. Get a little bit further there, maybe that far. And then there's B off in the distance, okay? That's 084, okay? So now it asks, what bearing does B spot A with? So here's where we have to be careful. If we create another north, we're not doing a compass bearing, we're doing a ship's course or a ship's bearing. We always have to go clockwise. So as long as you remember that, we should be in good shape. What this means is we have to rotate all the way around in that direction. Now, to figure out that angle, we would have to know this angle right here in the corner. And then we could subtract them from 360 looking up above. Well, if you look straight up above, notice the angle in blue that we still need and that 84 are both on the inside of the parallel lines, which means they should add up to 180. Therefore, if we take 180 and subtract out that 84, the measure of that blue angle in the picture is 96 degrees. So we could label that. We don't have to put the 0 with that one. And if that angle's 96, but the course or the bearing that we're looking for is the angle in red from B back to A, well now those two they add up to 360. So if we just take 360 minus 96, the bearing from B to ship A would be 264 degrees. That's the course or bearing at which ship B would spot ship A. And finally, things get kind of intense with this next picture. A ship proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots. And a knot is just a nautical mile. It's how they measure their distance. Then it changes course to 230 degrees at the same speed for 3 more hours. How far to the nearest tenth is the ship from its starting point? Oh boy. So the first thing we need to do is generate a picture. And we just have to read one sentence at a time to make that happen. Let's look at the first sentence. A ship proceeds on a course of 300 degrees for 2 hours at a speed of 15 knots. So I'm just going to pick a point kind of in the middle of my paper because I'm not totally sure where this is going to end up when we're done. If I start in the middle, we should be in great shape either way. So here's my ship initially, and I'm going to draw my due north. We always have a north in our picture. 300 degrees is a pretty big rotation. That's going to be over 3/4 of the way around. So I'm going to go around, we'll say about there, and I'm going to go in that direction for a little while, and I'm just going to put a point. So that would be 300 degrees for that big angle. Now notice it says for 2 hours at a speed of 15 knots, which is nautical miles per hour. The length of that segment then would be 2 times 15, which would be 30 nautical miles. So I'm just going to label that 30. All right, from there it says, the ship then changes course to 230. Anytime it changes course, we have to draw our due north again. I'm going to create that. There's another north. And now we rotate 240. All right, so we're going to just kind of do another arc right here and go around. Halfway around is 180, so a little bit further than that. And there we go in that direction. Put another dot there. So this angle, this big arc right here, is 230 total. Now it says for 3 more hours. So remember, we were still going at 15 knots, same speed, for 3 more hours. 3 times 15 would make that side length 45 degrees. The question is, how far to the nearest tenth is the ship from its starting point? So what we would want to do is just connect our dot back to the triangle, and that's ultimately what we're solving for. So what we're going to do is just kind of figure out some information about this picture and use law of sines or law of cosines to solve. But this is as far as we're going to get today. Our goal in the next couple of days is to just create triangles and then find some information about those triangles out before we use those laws to solve.